Preventive techniques. Solidity provides the library keyword for implementing library contracts. This ensures that the library contract is stateless and non-self-destructible. Forcing libraries to be stateless mitigates the complexities of storage context demonstrated in this section. Stateless libraries also prevent attacks wherein attackers modify the state of the library directly in order to affect the contracts that depend on the library's code. As a general rule of thumb, when using delegates call, pay careful attention to the possible calling context of both the library contract and the calling contract, and whenever possible, build stateless libraries. Real-world example: Parity multi-sig wallet. The second Parity multi-sig wallet hack is an example of how well-written library code can be exploited if run outside its intended context. There are a number of good explanations of this hack, such as Parity multisig hacked again, and an in-depth look at the Parity multisig bug. To add to these references, let's explore the contracts that were exploited. The library and wallet contracts can be found on GitHub. The library contract is as follows. Contract wallet library is wallet events, open brace, ... Code comments. Throw unless the contract is not yet initialized. Modifier. Only uninitialized. Open brace. If number of owners is greater than 0, throw. Underscore. Close brace. Code comments. Constructor. Just pass on the owner array to multi-owned and the limits to day limits. Function. Init wallet with 3 parameters. Array of address owners. uint required. uint day limits. Only uninitialized. Open brace. Init day limits of day limits. Init multi-owned of owners and required. Close brace. Code comments. Kills the contract sending everything to 2. Function. Kill with 1 parameter. Address 2. Only many owners of SHA-3 of message.data. External. Open brace. Suicide of 2. Close brace. ... Close brace. And here's the wallet contract. Contract wallet is wallet events. Open brace. ... Code comments. Gets called when no other function matches. Function with no parameter. Payable. Open brace. Code comments. If message.value is greater than 0, deposits with 2 arguments, message.sender and message.value. Else, if message.data.length is greater than 0, wallet library.delegates call of message.data. Close brace. Code comments. Fields. Address constant wallet library equals 0xcaf ... Close brace. Notice that the wallet contract essentially passes all calls to the wallet library contract via a delegates call. The constant wallet library address in this code snippet acts as a placeholder for the actually deployed wallet's library contract. The intended operation of these contracts was to have a simple, low-cost deployable wallet contract whose codebase and main functionality were in the wallet library contract. Unfortunately, the wallet library contract is itself a contract and maintains its own state. Can you see why this might be an issue? It is possible to send calls to the wallet library contract itself. Specifically, the wallet library contract could be initialized and become owned. In fact, a user did this, calling the init wallet function on the wallet's library contract and becoming an owner of the library contract. The same user subsequently called the kill function. Because the user was an owner of the library contract, the modifier passed and the library contract self-destructed. As all wallet contracts in existence refer to this library contract and contain no method to change this reference, all of their functionality, including the ability to withdraw Ether, was lost along with the wallet library contract. As a result, all Ether in all Parity multi-sig wallets of this type instantly became lost or permanently unrecoverable. Default visibilities. Functions in Solidity have visibility specifiers that dictate how they can be called. The visibility determines whether a function can be called externally by users, by either derived contracts, only internally, or only externally. There are 4 visibility specifiers, which are described in detail in the Solidity docs. Functions default to public, allowing users to call them externally. We shall now see how incorrect use of visibility specifiers can lead to some devastating vulnerabilities in smart contracts. The vulnerability. The default visibility for functions is public, so functions that do not specify their visibility will be callable by external users. The issue arises when developers mistakenly omit visibility specifiers on functions that should be private or only callable within the contract itself. Let's quickly explore a trivial example. Contract hash for Ether, open brace. Function, withdraw winnings with no parameter, open brace. Code comment, winner if the last 8 hex characters of the address are 0. Require uint32 of message.sender equals 0. Underscore send winnings invoked with no argument, close brace. Function underscore send winnings with no parameter, open brace, message.sender.transfer of this.balance, close brace, close brace. This simple contract is designed to act as an address guessing bounty game. To win the balance of the contract, a user must generate an Ethereum address whose last 8 hex characters are 0. Once achieved, they can call the withdraw winnings function to obtain their bounty. Unfortunately, the visibility of the functions has not been specified. In particular, the underscore send winnings function is public, and thus any address can call this function to steal the bounty. Preventive techniques. It is good practice to always specify the visibility of all functions in a contract, even if they are intentionally public. Recent versions of SOLC show a warning for functions that have no explicit visibility set to encourage this practice. Real-world example: Parity multi-sig wallet, first hack. In the first Parity multi-sig hack, about $31 million worth of Ether was stolen, mostly from 3 wallets. A good recap of exactly how this was done is given by Hasib Qureshi. Essentially, the multi-sig wallet is constructed from a base wallet contract, which calls a library contract containing the core functionality. The library contract contains the code to initialize the wallet, as can be seen from the following snippet. Contract wallet library is wallet events, open brace, ... Function init multi-own with 2 parameters, address array underscore owners and uint underscore required, open brace, ... close brace. Function init wallets with 3 parameters, address array underscore owners, uint underscore required, and uint underscore daylimit, open brace, ... close brace, close brace. Note that neither of the functions specifies their visibility, so both default to public. The init wallet function is called in the wallet's constructor, and sets the owners for the multi-sig wallet as can be seen in the init multi-own function. Because these functions were accidentally left public, an attacker was able to call these functions on deployed contracts, resetting the ownership to the attacker's address. Being the owner, the attacker then drained the wallet of all their Ether,